I'm standing on my soapbox, and
That was a lot of soap.
well, this helps. So what I'm basically going to talk about is, I really don't want to stand.
Don't, then sit right.
I'm going to pull a Clyde Caldwell.
You can sit on the
Yeah.
step
That's why I
if you
brought
want
that
to.
stool, that's for people who want to sit down.
Yeah. This talk started 2 years ago as how I built my radio station. No, I'm not wearing the t-shirt. WDRT in Viroqua, Wisconsin. Viroqua is just a little bit east of the Mississippi, so we claim we're on the west coast of Wisconsin. It's a rural area. The town itself is 4,300 people, and we started back in the early 2000s. Hi guys.
Hello.
I'm just doing a little setup. We started in the early 2000s. A bunch of us got together and said, hey, wouldn't it be great if there was a community radio station here? And our reference was kind of Madison. I spent 20 years in Madison, Wisconsin, and I volunteered for most of those at Ward. And we thought, maybe 5 of us thought, oh, it'd be great to have something like that out here. So we started looking into it, and at that point realized that the FCC was not granting licenses for non-commercial educational radio stations. So we set up an internet radio stream, and I'll begin the formal presentation with that. So this is what our website looked like. It was an entirely handcrafted HTML site, and after I built it using the table tag, I learned how evil the table tag is in the HTML writers community, and so I converted the whole thing to dynamic CSS. But I forget when I grabbed this snapshot off of archive.org. But we had our homemade automation system feeding the currently and most previously 2 played tracks to this, and it had news and happenings about our plans to build the radio station. And at one point in about 2006 maybe, Petri Dish from Prometheus and Norm Stockwell from Wart in Madison came out and visited us, and Petri Dish talked about the state of LPFM and also said that he had heard that the FCC was going to open a filing window for full power stations, and he encouraged us to do that when that happened. And at that point we had already incorporated and had a 501c3, so that we were thinking ahead and really planning on doing it. And so the stream worked. The technology behind the internet stream, I didn't know anything about computer audio when I started with this. We scrounged a couple of Sound Blaster cards, and my cohort, James Hallberg, scrounged up a little 8-channel analog mixer that we used in the studio. And there's a picture of Jim in the studio with, so I think we had 3 computers. We had a player, which we used the open source player called Amarok for our playout engine. A mic, we had a stack of CD players. There was a cassette player in there. We even had a turntable for a while. And then we had a couple computers down on the floor. So that was the setup. This was in the abandoned high school when the consolidated high school moved into their brand new facility. They sold off the high school, and we had a little closet in there. So this is some of the open source stuff, software-wise, that we were using on that station. Amarok, we used Liquid Soap as the streaming encoder, and that sent the stream to an IceCast server, and I just glued it all together with a bunch of Perl scripts. So this is the audio chain. We started with 8-track tape player or microphone or what have you, that fed into an analog audio mixer. That was plugged into a computer sound card, that Sound Blaster that I used. And Liquid Soap encoded for Ogg Vorbis, and we sent the Ogg Vorbis stream out to a server that I rented, and that was running Liquid Soap. So these two computers attached to each other via Liquid Soap, and then Liquid Soap running on this guy sent it to the loopback address and sent the stream. It split the stream into an Ogg Vorbis, a high bit rate MP3, and a low bit rate MP3, and then sent it out to IceCast, and we had our throngs of listeners tuned in via whatever they wanted to listen on. This was from 2005 until 2009 we ran the stream.
So all these machines were like right there in your playback center or whatever?
Yeah,
Studio,
well,
except for the
these computers, so we had I think we had 3 computers in our little studio. We had a player, we had a file server to store all the MP3 files, and then we had the streaming server that connected out to the internet. Yeah, so 3 separate computers. And they were all cast-off computers. I had moved out to this area from Madison, and I worked for an IT consulting company, and I went and asked them if I could have some old computers, and they were happy to give me the old stuff that they had. So yeah, 3 computers in, well, I'm not going to go back that far. 3 computers in the studio, and then a rented server out in the cloud.
Okay, but that where it was being split up, or your transcoder, though, that was like something you went out
That was
out for a service provider.
yeah, I did all the software on that. That was a rented server with, it was basically a quote-unquote bare metal virtual machine. And so I had full access to that server.
Okay. Why couldn't you do that inside your studio?
We chose not to do that in the studio. A person could easily do that at their studio. If you have, the key issue is enough outgoing bandwidth to serve all of your listeners.
Okay.
That's the key.
Oh, I mean, so that's actually where all your listeners' individual streams are being generated. It's not
Yes.
going then to IceCast that's doing it.
Yeah.
Okay, I got it.
This
That is
This is the
IceCast.
server out in the cloud.
Okay.
Yeah. So we actually only sent a single stream from the studio out to the virtual server. And we were on a borrowed Wi-Fi link in our studio. There's an alternative high school that had a DSL connection, which, the outgoing bandwidth was maybe 1.5 meg at the time. And so we didn't want to use up all their outgoing bandwidth with our 3 streams for.
But even that stream you're using up you're in at what 10% of the bandwidth? Or?
Maybe, yeah. It was a pretty low amount. I mean, when you do the math on audio streams, they don't use much bandwidth at all.
And I've done the same thing at half a meg.
Yeah, sure.
Half a meg.
Yeah, easily.
DSL line. And used half of it for audio and half of it for other stuff.
Sure. Yeah.
And transcoded it.
Yep. So we graduated from internet only to an actual antenna. In the summer of 2010, so we suspended the stream just because I didn't want to maintain it. We suspended the stream for a few months before we went on the air, and I spent all my time building the radio station. We had crews of construction volunteers to help physically build out the station. We were in the physical facility is a storefront right on Main Street in downtown Viroqua, and the building actually began its life as a tractor dealer. So we knew we had a pretty good foundation for a building, they used to actually park tractors right where we were building the studios. And the condition from our landlord was that we don't build any permanent walls. And so we built 2 self-standing studios and isolated them to the best of our ability from the surrounding office space. So theoretically, you could break those studios down and move them out, but it's not going to happen. We ended up buying the building, so we can do whatever we want now. There was much puzzlement over connecting the equipment. This is one of our audio technicians, JJ, puzzling over the schematics and wiring diagram of our audio arts board. Lots and lots of homemade stuff. I'm sure you guys have similar experiences. This is Rusty building a studio monitor hanger so that we could isolate the speakers from the walls so that we didn't get vibration in the walls. And then we had the transmitter. The transmitter is physically located about 4.5 miles north of the studio. And we fell into a really fortunate situation with our local phone co-op. They had built a tower about 8 years before we went on the air, 100-meter tower, and at the time they had their business radio system on it. They had a cable head-end system up there, so they had about a dozen dishes up there, as well as antennas, receiving antennas, TV reception antennas mounted on the tower for off-air rebroadcast. And then there was one cell phone company on the tower. It was this huge tower that was basically almost completely unused. And I went and asked the general manager of the phone company if we could have some tower space for our antenna, and he was like, yeah, sure. So we now get tower space and transmitter shack space essentially for a trade-out for a few underwriting announcements. And we have, I think our transmitter space uses about 9 rack units because we've got a little Nautel VS1 down there with the UPS, and there's a couple other components not in the photo here. Even the transmitter runs open source. The Nautel folks chose to use an embedded version of Debian Linux to run all the apps on there. So this is their Flash application that they wrote for monitoring the transmitter. This is a photo that I snagged about a minute after we powered the transmitter up for the first time. So there's a shot of the finished studios with a bunch of volunteers hanging around out front. This is a couple of days before we went on the air. We built Studio B, which is back here. You can see the air gap between the 2 studios. We built Studio B first so that we could make all of our mistakes in wiring and setup back there. And then we built Studio A after that. So you can see through the window, Studio B is all set up and in use. And then we hired a local cabinet maker to make the desktops for for both studios. And so this is Jeff and Cabin Dave installing the tabletop for Studio A, and there's a more recent shot of Studio A, all decked out with all the equipment. I'll get into the specifics in just a second. And that's the office space, just for reference. So we've got probably 2,000 square feet of total space. So at the station, once we got on the air, we expanded our use of open source, and here's some of the logos of some of the tools that we presently use. Everything from ingesting audio and recording audio to our phone system.
What's the open source phone system there?
Asterisk. We're actually, right now, we're using the defunct Trix box. But I'm in the process of upgrading our phone system right now.
Free PBX is another
Yeah,
asterisk, easier to use.
Free PBX is probably what I'm going to go with at this point. Yeah.
And it goes both VoIP?
Yes.
And there's switches.
Yeah, the, Asterisk will work with hardware. We currently have 2 analog phone lines, and we switch those with Asterisk. We've got a Digium brand analog phone card that we control our phone system with Asterisk.
So you can use those phones on the air? You don't have to have like analog phones to?
Yeah, yeah, we have SIP phones in the station. And what I'm setting up right now is we're not putting our SIP phones on the air because I don't have a SIP hybrid. And so what I'm doing is setting up, I brought it with me, but I didn't bring it down here. It's in my hotel room. I'm building a Raspberry Pi with the Pi touchscreen interface with just, it runs a SIP phone app on it, and that's going to be our main phone system right now. Right now, we're just using Skype for calls, unfortunately. We're still using liquid soap to get our signal from the studio to both the transmitter and the stream. We use, I'm converting all of our audio workstations over to use Jack, which is it's an audio, a low latency, professional grade audio routing system. And I think I'm going to actually switch over our liquid soap streams to use NetJack, which will give us lower latency between the studio and the transmitter. Right now, the delay introduced by liquid soap between the studio and the transmitter is about 8 seconds. And I'd really like to get that down because when people listen on our in-house receiver, you know, it's always a delay between that and what the person in the studio is broadcasting.
Call-ins
So,
are fine too.
pardon?
Call-ins are fine.
Yeah, exactly. Yeah.
8-second echo.
Right, right. And it's not a dump kind of delay that you can get rid of.
What
So-
rate is the
It can be
STL
if
feed?
you use the
What
right
what rate?
Yeah.
We're using uncompressed audio. We've got a 10 meg dedicated Ethernet link between our studio and our transmitter, and so I'm just using uncompressed audio between there, just straight PCM. It uses it's like 420 kilobits, I think. I forget the exact number.
Uncompressed is about, would be normally 1.5 megs.
Yeah.
Is it that high? Okay.
Yeah.
Yeah, it's been so long since I did the math, I can't remember. Thank you.
So is that just for your online streaming, or is that also?
That's
streaming
just
at the
for
tower?
the FM. I've got actually 2 encoders. We split the audio, the analog audio, and I send it to 2 encoders, 2 separate machines, one for the stream and one for the FM.
And the encoders are,
The encoders are liquid soap.
okay.
And so you're talking about hardware machines or
Yes,
virtual machines?
2 physical machines we're using for our encoders. The brand I used is it's one of these specify your own components and build your own hardware, build your own servers.
You don't need much for it.
No, you don't at all.
A 10-year-old Dell server will work great.
Yeah, and I bought all new equipment for this, and I got 32 gig SSDs for, or not SSDs, they're just SD cards for the drives. This was almost 7 years ago that I bought this equipment, and SSDs weren't quite stable enough to be used in production at that point. But so I used SD cards, and I've got a screenshot of it in just a little bit, but I went with, for the studio player computers running Rivendell, I went with Audio Science cards, just because of the compatibility with Rivendell. For the encoders, I went with Digigram cards to take the analog audio in and encode it with liquid soap. So those are physical hardware devices, and the encoder for the transmitter sends it to basically an identical box that does the decoding, and that sends it to we've got an Orban 5500 doing the audio processing, and then that sends it to the transmitter.
So you don't need more than like a 10 meg link to actually do both your FM and online streaming?
Yeah, but we have a separate dedicated link to the transmitter, and then we just use our internet link to send it out to the
One
stream.
going to the transmitter is not exposed to the net.
Exactly, yeah, it's a private network. Yeah. Yeah, and, you know, when our friends at the phone company asked what speed we wanted on that link, I just said, well, 10 meg, just to have plenty of spare. You know, because we'll do, I mean, we don't use anywhere near the full bandwidth of that link, but, you know, it's a dedicated fiber basically for us, so it's not a big deal.
For your STL, you don't want to use your full bandwidth, because
Yeah, right.
if you use the full bandwidth, it's going to start
Hiccuping.
hiccuping.
The converse, well, I mean, I guess you're streaming in real time, so there's no way for it to get ahead of itself. But will it
Right.
kind of, and you want to keep your latency down, just for kind of object monitoring purposes, really?
Yeah,
You're talking the trade-off right there, because
Right.
you bumped into that too. You know, you want the least compression you can have on the stream, but then, of course, you don't have the buffering going on, which you have with a lower bit stream, where it can take up the hiccups. So you've got to be sure you're, and then with your wireless, then you're looking at jitter and stuff like that through the air, which we dealt with the TCP wireless links, where there was actually, you know, packets coming in and out of time sequence.
Yeah.
And without a buffer on that, it's going to start whacking. So we had to go back into a more compressed, you know, with a buffered mode until they updated the firmware on the dishes that somehow got rid of the jitter.
oh, interesting.
Yeah, so that was one of those weird ass things. I realized, oh, we're dealing with jitter here. Something you normally wouldn't matter unless these audio packets were coming in and out of sequence.
Yeah.
You know.
Is it possible to do like a VBR with just audio?
Their rate on audio, I don't know, I talked to the dish guys, yeah?
Would it,
Yeah,
would it,
certainly could, sure.
In fact,
Would it bring
variable
anything to the
bit rate
table?
Works better.
Does.
VBR does, you think, in your experience, VBR works better?
Variable bit rate absolutely works better. Higher bit rate is obviously better, and variable bit rate is because you don't always need all that,
Most times it's lower.
and most times it's lower. And I tend to use a rule of thumb that for your audio stream, you don't want to use more than half of your bandwidth. You want to leave it kind of, you know, whatever capacity you have, you don't want to go more than half of that. And if you're using a variable bit rate, your maximum bit rate obviously can't go above your maximum bandwidth. But I would easily allow the maximum bit rate of the variable to come really close to your capacity.
Right. No,
But whereas you can keep the average down.
Yeah, and I'm, like you said, I'm finding that 48 kilohertz uncompressed is about 1.5 megs.
So you could actually get by with.
Right. The standard uncompressed is about 1.5 megs.
And
That's
does
true.
anybody know if there's a standard, like a jack component, that will do buffering? Because it seems a shame to actually have to compress something and lose some fidelity.
Yeah. Jack definitely can do buffer.
Because I was thinking if you can get that safety buffer on the receiving end.
Actually, you can, well, remember I was talking to you yesterday about, if you want, we can have a little get-together and I can do a little explanation of the theory of this lossy compression, give you some understanding about how it works and how something like a 500K Ogg Vorbis stream, you might call it lossy compressed, but it really isn't. It really is. And so that actually works very well, provided that you can take the latency.
It's all the trade-off and balance there.
It's all trade-offs, yeah.
All trade-off.
One of the advantages of a small network is that you can put it on one slide and have the whole thing there. So we've, at our station, we've got, I think 5 VLANs. We've got a 48-port switch. At some point, I'm going to start playing with some of this open net, the terms just escaped out of my head. Some of the open networking stuff where you have a network controller that's physically a separate component from your switch. Right now we're using a Cisco switch because that's what I'm most familiar with. So we've got a bunch of VLANs. We've got a separate network for the transmitter, and that rides over that dedicated Metro Ethernet link. We've got a studio network link, which includes all of the Rivendell components, including the database. We've got an office network, a phone network, and then the internet component as well. So here's a shot of our, so here's overlaying the various open source components in each of those locations. There's a shot of our studio rack with the various components in it. We basically have 2 computers right now in each studio. We've got the workstation, which is connected to its own fader on the board, and it runs Audacity for editing audio. And as far as I can tell, it's been up to every task that people have asked it to do. I know there are better and more competent, I would say, audio editing and production tools out there, but we seem to be doing okay with Audacity at this point. We're running into a few conflicts between people trying to browse the web with, listen to YouTube videos or whatever, and Audacity, and I'm sort of struggling with that, and I'm about to separate those 2 functions on separate computers at this point. Yeah.
May I suggest Acoustica out of the UK? It's a $50 package, and it allows you access to a giant library of sound effects and music tracks and components. It's a multi-track recorder. It's very stable. It tends to always be about $50. They keep releasing an upgrade, but it's just got a wealth of a library of stuff you can use, especially sound effects and things for production. And it's home DAW for music production.
Yeah,
but
yeah.
$50, it's a really good stable and really good database of sounds on it. Acoustica.
Okay, thanks.
Do multi-tracking?
Yep. It's really full-fledged.
So in addition to the audio workstation, we have a dedicated computer running the Rivendell player, and that's basically all it does. It runs, the component of Rivendell is RD AirPlay, and that computer just does that. So like I said, I'm probably going to add a 3rd computer to the mix so that we can keep the audio functions separate from just, internet browsing and stuff like that. So that's the studio side of things. We also use Mix, M-I-X-X-X, for DJs to do like live mixing during their live shows. Audacious for just general playout. And then the usual array of Office apps, which I'll talk about in more detail. Then in the back, we have a couple of racks of equipment that do various things. Our phone system is behind this monitor. This monitor is actually, we have another great thing about our phone company is that they run an IP-based cable TV system, and they gave us our own TV channel on there. And right now, we have a camera in the studio, and if the DJs want to be live on the TV, they can switch it over, and if they don't, they can just flip a switch, and we've just got a continuously running slideshow that goes with the audio. So that's what this display is showing. We've got a virtual host that houses about a half a dozen virtual machines. We've got a file server that's based on FreeNAS, which is a BSD Unix-based file server. You probably recognize the Sage NDEC. Even that runs open source software. It's a Linux-based box. You don't know that, but it is. And then our transmitter encoder is this little 1 rack unit box. And the stream encoder, we decided to go with a bigger form factor because you can put bigger fans in them. And this is right in our office space. And with the teeny little 1-inch fans, they scream. And so we decided to go with quieter boxes in the office space just so that the racks weren't making so much noise. So that's the studio end of our back end stuff. And then up at the transmitter, got the modulation monitor up here. We've got a little, actually this is, I've replaced that with a Cisco switch as well. But at the time I took this, it was a little micro-tick switch running OpenWRT. Got the Orban processor below that. Oh, there's the audio decoder, which runs Gentoo Linux and Liquid Soap. And then the transmitter, which runs Debian. So when I first gave this presentation 2 years ago, the uptime on this was like 1,500 days. And I just took a snapshot of it the other day, and it's 2,100 days. It's like a month shy of 6 years that server's been running.
And this is your player?
That's the decoder up at the transmitter. So my view of using open source in an environment where there are a lot of people using the apps is that you've got to have somebody on staff or as a dedicated volunteer to really believe in the idea of open source. And so I've been at the station the entire time. I helped build it, and I've been a resource there. I haven't always been actively involved, but there's always been somebody there that gets the technical side of things and has been willing to work with the open source tools. The idea of, I just want it to work, I want to go out and buy something and make it work, it doesn't cut it. One of our mission statement goals is to be an educational resource, and the staff and the board believes in the idea of open source at our station, and so they're willing to put up with some of the inconveniences of having to learn how to do some of this stuff yourselves. I mean, I didn't know, as I said before, I didn't know anything about audio processing when I started our stream 11 years ago in 2005. And I've learned a ton, and I still don't know that much, but we've got it far enough along that we can make it work, and people are reasonably satisfied with it. And so we've learned, you know, we could have gone out and bought Barracks boxes to be our stream STL or our studio transmitter link, but chose to do it ourselves and figure out how to do it and figure out what all the components were. I mean, one of the advantages of that is when it breaks, you can fix it, right? You don't have to depend on a vendor to be responsive in a timely way. So we're using it as a teaching tool, and we've got a small tech team. We've got half a dozen volunteers that come in every Tuesday night, and I'm sort of mentoring some of them and helping teach them about open source, and they're helping maintain this collection of stuff. So, you know, we could have gone with Shoutcast as a server and called up, you know, the stream guys or Live 365, but we chose to do all of this ourselves, partly as a learning experience and partly just to, you know, to have some additional fun on the back end with stuff. So, you know, you can do the straight, you know, let someone else handle it, or you can do it yourself and learn something along the way, or you can do some hybrid of it and do a little bit of each. Using open source might require a little bit more training of apps. For example, we use the LibreOffice suite of Office applications. A lot of people know the Microsoft suite of applications. It turns out that learning the LibreOffice suite is not that big of a stretch for people who know how to type documents in MS Word or whatever. So there's a little bit of a training issue here, but my experience so far is that it hasn't been that big of an issue. When it comes to hardware, we've built our own remote broadcast system, again, Lenovo hardware for the laptop, and we take a USB sound device. I have one here that I just brought, and I'd be happy to show you the current state of this, but we could have gone out and gotten a Comrex that does the same thing. We have taught about 4 people the in-depth super details of the software that's running on that laptop. And we have a pool of folks that can go out and help with remote broadcasts. It's to the point now that we've got it where you turn the laptop on and it's immediately attached to our studio end of things, and all the person in the studio has to do is pot it up and they're on the air. So there's really not much work at it at this point. But if you dedicate your time and effort to open source, you also have to realize that there are maintenance issues. If you make any local changes to any software, which you can do, here's a screenshot of some diffs that I made to liquid soap to fix a bug that was bothering us. I submitted it upstream, and it was accepted, but if it wasn't accepted, you've got to maintain that if you want to ever upgrade. So there's a little bit more overhead there. You've got to want to commit to the open source idea if you want to do it. So I've realized that there are some common themes between open source communities and community radio communities. And I just sort of thought I'd highlight where these two overlap and some of the commonalities between them. Obviously, it's a big DIY thought process, mindset. Definitely grassroots driven. Open source started with people saying, I want it, Linus Torvalds said, oh, I want an operating system that I can use as a terminal emulator, and he started writing the Linux kernel. People have this mindset of being able to do a lot with very few resources, and they build their own resources along the way. I think that both the open source community and the community radio communities are sort of meritocracies, where if you accomplish something and you're successful, you get rewarded for that, and you can build from there. And I also think that that both of these groups of people are definitely into sharing. I mean, the reason we're here today is to share information this weekend. I think there's a big ethos of that in the open source world as well. So I've actually given this presentation at a Linux conference and had great reception to it, and people are really, it seems this is a natural fit, the open source communities and the community radio communities. And so I thought, well, I'd put this talk together and share my enthusiasm for it. So that's kind of where I'm at, and I'd love to continue the conversation with you. And I know you've had input, and I've appreciated all your suggestions and comments, and let's keep it going, okay?
Yay.
What's up with this PV panel?
Oh, I'm talking about solar later.
Oh, okay.
How to power your station.
Other thoughts? Mike?
Okay, so I'm curious, if you have your VLANs, why do you choose VLANs as opposed to have everybody just riding together?
I spent 20 years doing networking, partly as a kernel developer and partly as a consultant for enterprises. And it just seemed like a natural thing to me to segregate the traffic so that the audio traffic didn't have to compete with people surfing the internet. That was the main reason, just to segregate it so that we could assure the performance we needed on the audio side. You know, the central switch is a 100 meg switch, power over Ethernet, so that we can power our phones. And in general, 100 meg is enough, but the thing that we're learning, we have our policy, our station policy allows volunteers to pre-record their shows if they can't make it to do their live show. And so many of the shows are 2 hours in length, and people will come in and they'll basically do their show with Audacity running, recording the show. And when you end up with a 2 hour long show, a 2 hour long piece of audio, it's a lot of data to deal with. It's not a huge amount of data, but one of the things we've learned is that a 100 meg network is too slow for that. And so if we hadn't segregated all this stuff into VLANs, we would have had even more contention. And so the VLANs are mostly a performance issue. Do they give us the kind of performance that matters? I'm not sure. I'm actually about to upgrade the studio workstations and the file server to gigabit connections. The file server is actually on a gigabit connection, but the studio workstations where people are actually recording their audio, because they save everything to the file server, not to a local disk. And 100 meg saving to a file server is kind of slow.
It's also dangerous. I mean, so I've had a lot of my DJs lose their files when they're trying to save it across the network.
We haven't had any, well, we've had a few small losses, but we haven't actually had anybody lose an entire show saving across the network yet. Audacity is pretty good at recovering crashed instances of the running program.
Are you just copying it, or are you just essentially making the recording?
We always tell our DJs and engineers to save locally. You know,
Yeah.
to save on the local machine and then move it to the network, but sometimes they screw up and they accidentally start saving it to the network. And
Yeah.
if it's a heavily congested day, if there's a lot of people in the building that day, then it can
But if
screw
they
up.
want to take it with them, that's the logistics problem, because they have to wait till the end of their show, they're rendering it out, the next DJ's coming in, you got a problem.
Yeah.
That's what we have.
Couple of things. One is, I like to set up computers with 2 network cards, and within the station, where one of the network cards is for the web browsing, going outside, stuff like that, and the other network card is is strictly a local network. It's strictly within the studio. So you were saying VLAN. I'm saying 2 separate LANs, physically separate wiring. And of course if one card is better than the other, of course you put your local network, the more critical one, on the better card. And of course the reason for that is to segregate the traffic. Another reason for that, something that helps, is that if the station has its internet from more than one provider, let's say we have both a DSL and a cable or something like that.
That's a real luxury.
And, well, sometimes
And it's a pain in the ass.
it's a pain in the ass, but also sometimes it's the only way it works. Because if you can only get consumer type connections and
Sure.
and that's what you're stuck with, and maybe they give you a good deal or whatever, you might want maybe one public network in the studio and the other public network in the office, so they're not, so that any particular computer might be on one or the other, but within the station, the second network card means that they're all on the same local network for purposes of sharing. Another comment about Audacity is that Audacity must be configured, practically speaking, to store its temporary files locally.
Yeah.
That if you have a situation, even if it's accidental, where the Audacity temporary files, which are the huge ones, are stored over the network, it will crash.
Yeah.
Problem solved by storing them
So
locally.
what do you do? Because we're running up against like them wanting to render it out at the end of their cast, and the other guy's coming in, and
Well-
it takes time. And
Well, the way I've set up the computers is that the home that they log into, which actually the way I set them up is that there is one home that they log into. It's radio with the password radio, so that it's something that everybody knows that. This is kind of the generic one. That gives you a home directory that's local to the machine for your quick stuff. But there's the networked storage area that is where you're really supposed to store stuff. The home directory that's local to the machine is strictly local to the machine, and you move it to somewhere else. But the main reason for that is because all the dot files and stuff like that are there. So that way they don't
Yeah, we
with
do
each other.
something very similar at WDRT. The user is called WDRT, and their home directory is local on all the machines, and you have to kind of go out of your way to put something on the network drive. It's just called share. It occurred to me that, Ken, I know you've said in the past that you use some open source at WFMU, and you made the decision at some point to stop doing your local maintenance of distros, and you went with Red Hat, and which is an open source company, but it's also they also provide commercial support. Has that been successful for you?
Yeah, we had to go to Red Hat because at the time, I only had one full-time IT person, and he was just spending too much of his time updating Linux and just dealing with all that stuff, and it was just way more cost-effective just to have a contract with Red Hat.
Sure. What distribution were you using before?
And we were just maintaining Linux ourselves.
A Linux from scratch type thing?
I'm not sure. Ubuntu, I'm not sure.
Yeah, so
And then also to get to your question about DJs in a rush to save the file on their way out the door, we did that at first, but we very quickly realized the exact problem you're talking about. So we set up 2 machines in Studio C that just automatically record every single show and automatically update it, upload it to the.
Throw another machine in it, yeah.
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 Because it's too much of a problem to ask the DJs to record their own shows.
right. Yeah, we're doing that as
Actually,
well.
right along with your stream.
Yeah, we're doing that. Liquid Soap has the ability to output multiple places simultaneously. So we keep 1-hour chunks of Ogg Vorbis files permanently. We've got them going back to the first day we were on the air.
It's rolling all the time.
Yeah.
We record every show on WFMU proper, just from a studio down the hall from the main studio. And then we have multiple channels, and on those multiple channels, we attempt to rip the streams. We rip the archives from the stream, and that just doesn't work very well. It just has a really high failure rate. So those DJs often record their own show in addition, so we always have a backup.
Couldn't you do that for Rivendell too, to set a clock to
Yep.
poll every hour and
Yep.
save it to, okay.
Yeah, you can. Yeah, Rivendell will record from arbitrary locations. It doesn't have to record what you're playing from Rivendell. It can record anything, and then you can also schedule it to upload that to wherever you want. Rivendell also has the ability to turn its audio into formal podcasts. It will create the RSS feed for you and everything, so you can actually use it to do some podcasting. We don't use that because we wrote a separate tool for that kind of stuff. But and we do we manipulate the audio a little bit differently. For example, if somebody has a 2-hour show that usually starts at the top of the hour and ends at the top of the hour, it doesn't always. As you know, we call it Kickapoo time where we are. We're in the Kickapoo River Valley, and time is very fluid. So things don't start at the top of the hour, but we want to capture the entire show. So if it starts a little early, we'll pick that up. So we actually we chunk our 1-hour pieces. We go in and automatically edit. We take the last 3 minutes of the previous hour, the entire first hour, the entire second hour, and then go into 3 to 5 minutes of the trailing, the beginning of the third hour.
Is there a way to do that for Rivendell?
No, you can't do that with Rivendell. We use the audio editing library called SOX, S-O-X, to do that.
So you're actually, for that 3 minutes, you're creating 2 files simultaneously. Hour 1
No,
or block 1, block 2.
Liquid Soap is writing one file at a time. So it closes the previous hour and starts the new hour. We have a separate Python script that goes and extracts the last 3 minutes from that first hour, that previous hour, and then it extracts the entire first hour of the person's show, the entire second hour of the person's show, and then it grabs the first 3 minutes of the next hour after that person's show.
It's just a pending after that.
Yeah, yeah.
But we wrote our own thing that does the exact same thing, and it does record 2 simultaneous files.
When I started many years ago, we recorded continuous 5-minute chunks,
Oh.
and they were set up so they were like to the millisecond roughly, and they were seamless. And so
Yeah.
the DJ problem was solved by when you got done with your show, and they were recorded straight onto the network drive in a well-known location, so, and time-stamped, obviously. So when you're done with your show, you go to the other computer, some other computer in the studio. You have to wait until the 5-minute chunk that ended your show is up, and then you select them all and burn, because it was CDs then.
Yeah, yeah.
And that worked pretty well. And then as long as you play them back without pauses between tracks,
Right, right.
you're in good shape. And then that formed the source for also amalgamating and turning into podcasts
Yeah,
and stuff.
yeah. And you have little chunks to deal with, little pretty high degree of granularity.
Mm-hmm.
Nice.
And then you can, if your show was starting early, you could grab the 5 minutes
Yeah.
before, and yeah, turned out to be a pretty good way to do it. Now, a lot of the DJs would still record their own stuff live on the studio computer, and that was a problem.
Is anybody doing air checks? So when you actually turn the mic on, it starts recording?
No skimmers.
Yeah, right. I mean, when I worked in commercial radio, we had the union engineers set it up and just attached it to a cassette tape with the old cassette recorders had the mic switch, which it was always recording, but the transport wasn't moving, so they just turned on the cassette while the mic was on. I want to set something like that up for our DJs so that we can do better air check and review of how the show went.
We have the timer button, so when the mic goes on, the timer starts counting up, so at least the DJ will know how long they've been talking.
Yeah,
'Cause
yeah, right.
DJs realize that a 12-minute mic break is a little bit too long.
Yeah.
On the Rivendell, starting and stopping recording, you can set up macro cards in Rivendell to do that, and the macro card can be put in your playlist. So you can actually have things like, here's the station break. It does ID, blah, 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 start your recording, and then go on. And you can make it blend in with your station break running stuff that you do already.
Yeah, you can do that. That I would consider a little bit more advanced use of
Yeah, oh,
Rivendell.
yeah.
You're not going to get a DJ to set
Well,
that up for their show.
You're not going to get a DJ to create the concept, but
Right.
if there's a button on there that
Yeah,
says
true.
start recording,
Yeah.
and you put it in your playlist,
Yeah, good
you
point.
put it in your playlist, you can tell it right then when to start and stop.
Michael?
So when you're showing your picture of the different boxes in the racks, you had like that virtual machine box. What applications are your VM used for?
Yeah, we have a general network utility server that it acts as our internal DNS and DHCP. Our Rivendell database is on a virtual machine. It's a Debian server that runs MySQL. And we have our archiver, the thing that runs those Python scripts. That runs on a virtual machine. We have an in-house IceCast server that we use for remote broadcasts. So when we take this laptop out, it's set to automatically attach to that IceCast server. And then in the studio, the DJ on the operator on the air just has to tune into that IceCast stream to put the remote on the air. So that's 4 or 5. There's a handful of other just utility machines that we use as well. Oh, the phone system is a virtual machine. The new phone system, because the existing phone system has a physical piece of hardware, so we dedicated a computer to that. But the new phone system will be voice over IP only.
So, point of reference, in 2003, the station I set up had like one sort of server, and it had the storage and everything on it. VMs weren't really in use then much, and there was a studio computer in each studio. And we ran all of this except the phone system without any VMs, just fine, on a Pentium, whatever it was, with a RAID array. So, I mean, these days we have a lot more options, but really you can get away with a lot less.
For sure.
So what applications would you choose? A Pi, Raspberry Pi?
The one that I'm working on right now is a dedicated, I mean, it's basically, I'm turning the Pi into a dumb smartphone. So it's got a 7-inch screen with the app, when it boots, I can bring it down at some point, I brought it with me. The system, the Pi boots and it automatically runs, the one that I'm using right now is called SFL phone. It's a SIP client with an on-screen dial pad, and what I'd really like is like something like an iPhone or an Android phone, take the phone app and put it on this thing. I haven't found any open source like dedicated phone apps. The thing I've got on there now is just it's in the Debian repository, and so it's doing that. One of the things I intend to do is rebuild our STLs with probably not Pis, but there's another open source small hardware platform that's in development right now called Udoo, UDOO, and it's a full-on 4-core x86 processor, so it'll run Windows, it'll run Linux, and it's like 3 to 5 times more performant than the Raspberry Pi. The Raspberry Pi ARM processor is, I'm questioning whether it's up to the task of encoding audio reliably. I'm sure it is, if you don't do anything else on it.
Yeah, I've done it on 400 megahertz.
Have you?
For Pentium.
Okay. Yeah, right.
I mean, it depends on what encoding they're doing.
Yeah. So, I have a project in development doing a phone. I'm sure there's tons of things that you could do with it. Al, you've probably done stuff with Pis, no?
No, I haven't.
No? Okay.
Actually, I've been too busy.
Yeah.
And what do these phone systems do? Do they take incoming POTS lines, or do they have to take C1 lines, or what?
Our phone system can deal with POTS lines, T1, E1, and SIP lines. We're currently just using POTS and SIP lines. And it's pretty amazing the things that you can do with the asterisks with something like FreePBX on top of it, because you know, we don't always have a staff person in the office, and so we've got our phone system set up so that you get a menu when you first call in, and the first option is to hit 1 to try to reach the person on the air right now, and that will ring the phone. It's a visual ring in the studio.
And the telephone hardware itself is a multi-line phone?
Yep.
And can it be any number of brands of multi-line phones?
Yeah, there's a bunch of SIP phones that are available. I chose some $60 phones from China that I found, and we've had them in use for 6 years, and they're holding up just fine. They've got little LCD displays on them. They don't have super numbers of features, but they'll do multi-lines and hold, transfer, all the other stuff.
This one usually get parts for them, but I mean, I see that wear and tear on wire that goes for handsets.
Yeah.
The handsets themselves.
Yeah, ours have been okay. I mean, the coiled cords get twisted and knotted, you know, like everybody. It's all standard cords, so you can replace them easily. How are we doing for time?
We're just about out the next, we're over the hour, but
Okay.
like 7, 8
Yeah,
minutes.
I'm happy to keep this conversation going in the hall.
Yeah, I feel sorry for anybody that didn't get to go to this lecture.
Thank you.